This is our Arduino. Meanwhile, you should know. We have a bunch of digital in and outputs. These digital in and outputs do deliver. As output, they deliver 5 volt and maximum 20 milliamperes. But now, and this means welcome to an exercise with power. Now we want to start up an engine, a real motor with our Arduino. Well, you probably have now something in mind which looks a little bit different than what I show you, because we do have a motor in our starter kit. That's this thing here. So this is the thing we are using. This is our motor. Yeah, tiny, I know, but still too much for our Arduino. Here we take up to 500 milliamps if we're stalling it. So if we hold it, then it takes 500 milliamps, and it's designed for 6 volt. Should not really bother us. So we're using 5 volt. So maybe it's just 450 milliamps, but much more than our 20 milliamps from our Arduino. So I cannot just plug it in here. It's not working, or at least not very long. One thing we can use to turn on and off bigger loads is this here. That's a so-called relay. Okay, it's a so-called relay. This relay here, it's written on. It has a 5 volt DC coil current, coil voltage, and it can switch up to 10 amps. So this is something we cannot. 5 volts does fit our Arduino. So this is something we can use to switch bigger loads. What is a relay? Okay, so let's have a look what a relay is. A relay is nothing more than a switch which can be actuated by electricity. Okay, how is this working? We do have two connectors. They are called A1 and A2 usually. Then we do have a piece of metal. Maybe look a little bit different in reality. And then this metal is ferromagnetic material. Okay, then we do have a coil around this metal. Okay, so if we apply here now some voltage, then there will this metal will be magnetized. It's nothing more than an electromagnet. Okay, this will be magnetized. Here we do have some iron plate, also ferromagnetic material. And this is here somehow bolted, or it simply is connected. Here we do have a spring loaded, which is fixed here. So the spring will press this in that direction, and it will lift automatically. Okay. If we now apply here voltage, then here is a magnet. This magnet will bring force to this iron plate. This iron plate will then get to the magnet and touch it. Yeah, the spring will be loaded. Okay, that's it. Yeah. A little bit more we have here also. Here's the big one. We have here also one connector. Yeah. We have here one connector. And we have here a switch, a tongue. Yeah. And there is also, this is also electrically connected. And all together is placed in the housing of our relay. So right now those two are connected, this with this, and if it's then switching, it will look the other way. Yeah, then it will look this way, that this is connected here. Yeah, it simply moved. Yeah, cluck 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 cluck. So this contact here can either be connected to this or to this. If it's not energized, it's connected to this contact. That's the so-called normally closed contact, and this is the normally open contact, and this is the common. Yeah. Okay, so the common is usually connected to the normally closed, or if activated, switch to the normally open. That's it. And because these contacts here are much more rigid and much more even in this tiny little thing here, we can deliver more power, because then we can switch also bigger currents. Clear, right? So normally closed, or in German this would be an Öffner. Normally open, in German this would be a Schließer, and there is the common contact. There are relays out there with several contacts with just one coil, and several contacts which do switch all at the same time and so on. Our relay here, if we turn it over, here you can see exactly 4 contacts. 5. Of course, 5 contacts. The common here. This one is the common. Then we have the coil, which is these 2 things. And then we have the contacts for common, normally closed and normally open. And everything else is in there. This is our relay. This is how a relay works. Let's have a look at the datasheet. Here we got the datasheet of exactly this relay. Okay. So here we can see the schematics. So this is the common. This should be the coil here. This is the typical symbol of a coil. And this is the normally open, and this is the normally closed contact. So far so good. Let's have a look on our coil data chart. Okay, the coil data chart. We do have, if you remember, there was written on the relay was written SRD. This means standard coil. Standard coil. We do have voltage 5 volt. Yeah. So the nominal current is 90 milliamps. So even this tiny relay is overwhelming. It's overwhelming our Arduino. We can only deliver 20 milliamps. So it's a nice approach. We will try it. However, we have to find something which is powerful enough to switch the relay. This is it. This is a so-called transistor. Transistor. What is a transistor? Transistor can be used for a lot of things. This one is a so-called NPN transistor. It's labeled on the top. You should read there S8050. S8050. Then you have the right one. There are also PNP transistors in your starter kit. We are using this one, NPN transistor. Okay. What the differences are, I do not want to talk about this right now because it would be too complicated. Because right now we are only using this transistor as a switch. Okay. So as you can see, this transistor does have 3 legs. What these 3 legs are about. The symbol of a transistor looks like this, at least from an NPN transistor. This is our transistor. Okay. One connector is called the collector. One connector is called the base, and one collector is called the emitter. Okay. The way we are using this is simple. If we apply here voltage, bigger than the emitter, here we have got a voltage drop at these bipolar transistors of around 0.6 volts, 0.7 maybe, 0.6. Like on a diode. It's nothing more than a diode inside there. 0.6 volts. So if we are getting above this value, the 0.6 volt, suddenly the connection between collector and emitter is starting to conduct. If there is not that voltage here, collector and emitter is closed. There is no connection, electrical connection possible. Okay. So what we are doing is we are connecting this here to Arduino. So we have here plus 5 volt. Okay. We are connecting this here also to plus 5 volt. And here in the emitter we're placing our relay. Okay. And here we go to ground. Okay. So we do have here plus 5 volts between the Arduino and ground. Here we have our plus 5 volts here. Here we have 0.6. So here we only have around 4.4 volts left. That should be sufficient to switch the coil. No issue. This here is only, usually you do it different. Usually I make it now in green color because this here is our special case. We are just using this small tiny transistor in that way. We could also use a transistor to switch, I don't know, some of relays are not using 5 volts on the coil here. They're using much more. They're using 24 volts for instance. And then I could come to the idea I'm using 24 volts here. That's not a good idea. That's not a good idea because then here it's 24 volts, here is still 5 volts, here I have 19 volts and the current. So there is a lot of power consumed by this transistor, and this will not really switch. So this is not a good idea. Yeah? Because the usual way of how to connect such transistors is this. Here we go directly to ground. And here we have the coil. And here we have plus voltage. Yeah. All right. And here, the issue now here is we still have here around 0.6 volts. Yeah. So I need to have a resistor in here, base resistor, and then have my control voltage plus 5 volts. Yeah. And here we should have this 4.4 volts around. Yeah. And here in there this base current is flowing, and I need to know how big is my base current. There is something called current Verstärkung, Stromverstärkung, current gain of my transistor. Then I need a lot of data of this transistor. Yeah. However, if I'm using something else than 5 volts here, this is of course the recommended. This is recommended anyway. Yeah. This one we are doing because we can. Yeah. Because we have both times 5 volts, so nothing much could happen. If we have something else here, then this is a possible variant. You need to calculate how big this RB is. However, for our case here, this should not bother us. Okay, so we're using this one. Now let's have a look on our transistor. You see there is a flat side, and a round side. The flat side is where it is labeled. Okay, there it is labeled on the flat side. And from the connectors, if we're looking at the flat side, the left one is the emitter, the middle one is the base. The left one is the emitter, the middle one is the base, and the right one is the collector. Yeah. This left, middle, right, like it would be pulled in this way. Yeah. This is how this is connected. Yeah. So we are going to use exactly this setup. Okay, we are using exactly this setup. This I want to build. There's one thing is still missing. I mean, if there's so much current or so much power involved, how do we get them? I mean, also our plus 5 volt on our Arduino does not supply unlimited power. So there is something inside your starter kit which can. This is this thing here. This thing is a power supply. Yeah, it can supply enough power. Yeah, and it has 2 power rails. Yeah? You can connect here battery, pretty much the same voltage like on our Arduino. Yeah, battery or this adapter, AC adapter. Yeah, or you could even supply it by USB. Yeah? Here is a power switch. You can turn off and on the power supply, and the power will go out by these connectors on the ground. Okay. Why are they looking like they're looking? Because they exactly fit into our breadboard. Please be aware of that you're using the right side. There is one side labeled with plus, yeah, and the other side is labeled with minus. you should try to plug in on the correct side of the board. And you also have to take care about the jumpers. You see there are jumpers, and you can select if you want to have here 3.3 volt or 5 volt. Okay, currently this is set to 5 volt and this is set to 3.3 volt. I will set now both to 5 volt because then I do not care which one I'm using. The ground is always connected. Okay, so here's the plus side, here's the red rail, so I will plug it in that way. Okay, if I want to have the connector on the other side, was easy, right? Okay, so now I am building up this one. Yeah? So I'm using my transistor. I have to spare the legs a little bit, split them, and then it's fitting in. Yeah? Then it's fitting in. Yeah? So I have here emitter, base, collector. Okay. Take care about the direction. Yeah. So where do I have to connect the collector, which is on that side? I connected to plus 5 volt. Yeah. Plus. Where I have to connect the emitter I have to connect to my relay. Yeah. I will use the relay on the breadboard here. It does not fit perfect. Yeah, it does not fit perfect at all. Yeah, it's again a case for gentle force. Okay. So let's see if I can manage this here without bending too much. Let's hope we are connected. Okay. So I have to connect it to A1, yeah, the emitter. I will use an orange one to sign to show, okay, there's already something switched. Yeah. Here, this side, I'm connecting to the emitter, the A1, and the other side I'm connecting to minus. I'm connecting to minus. Okay, this does not look too bad, I would say. Yeah? So you could either use this AC adapter, which I will use this now, this AC adapter, which is part of the delivery. So I will simply plug it in here at my desk, and turned out not to be that simple. Still already working. Yeah, connected, turn on. Okay, something hot? Not really. Looking good, I would say. Yeah, looking good. So I will take now my motor. Please note, I have done several fixes on my motor because those little connectors here, they tend to get loose. So then you have to solder again. I use this cable binder, this binder here, to fix the cables so that the mechanical stress is not going directly to the soldering point. Okay. Then this is usually an issue, how to grab it and then hold it and so on. So I'm using a tweezer. a tweezer, a clamp or something like this. Clamp it here, because then it will hold itself. Let's see if this thing is turning now. I'll plug it at minus, I'll plug at plus. Yeah. Working. Yeah. Wunderbar, wunderbar. Some are already satisfied with this. Well, we are not. Yeah. What we have to do is we have to connect the common. Where is it now? Here. Here's the common to plus 5 volt. Yeah. And then we have to find out which one. We have to find out, is it working here also? I will move a little bit closer. Yeah, baby. And this side, it's not connected. This side, it's also not connected. Ah, that's bad. That's bad. Because then this thing did not really found its way perfect. It's perfect fit. Okay, better. So this connector here seems to be the this connector here seems to be the normally closed, because we are not switching now. This connector here seems to be the normally open, because it's not working. Yeah. See if I find a better suited clamp here. I got one. Where is this? Ah. Okay, works better. Working? Yeah. So, what we need to do is we want to switch the relay. Let's see if this is working. No. emitter base, so we are at plus 5 volt here. Let's see. Okay, directly from our, okay, now this is clear. Yeah, so here it's working, and here also here. Okay, switch it off, switch it on. So here I have plus 5 volt or nothing. Yeah, so this the transistor seems to work. I've just tested it with the motor. You see, the motor is turning or not turning. So the issue must be here with the relay, and this is always the case since it is not perfectly it is not working perfect. Simple. Aha. Ah. Yeah, if you don't connect the second side, so you see, basically our setup is working. And what you also hear, I mean, you hear of course the motor. Yeah, brumming. And if I now disconnect the motor, what you can hear here, you hear? These are the connections of the relay. Okay? Click, clack, click, clack, click, clack, click, clack, click, clack. You hear them. Good, good, good. So reconnect. This one we don't need anymore. We managed to build this. Great. Okay. This is working. Now Arduino. Okay. Where to connect this? I need a longer cable now. Where to connect this? This is of course connected to an digital output, because now I want to control this transistor with a digital output. I will simply use 2. Okay, I will simply use 2, and I'm satisfied. There's one thing still missing. There's one thing still missing, because only because my Arduino thinks it is 5 volts, it is putting out. This here might have other 5 volts. So I still need to connect the ground to each other. Ground and ground needs to be connected, because then they have one particular reference value. Okay, now they have one reference value, and if it puts out 5 volts here, this one understands 5 volts. Okay, that's absolutely necessary. So let's just put my Arduino on the other side, Let's connect the Arduino. It's coming alive. Okay, Arduino has come alive. This cable still looks a little messy, but this is just the way it is. Okay, so that's our hardware setup. Now let's start to try if we can control the motor with our Arduino. Okay, so let's start with a new sketch, save it under decent good name. It's 23 already. Relay control. Enter. Setup. I define again my motor pin, and this I've connected to pin number 3. And I define a motor on time. I would say it should run for 5 seconds. And I will define a motor off time. This was not an F, and this should be, let's say, 2.5 seconds. Then I of course have to write the pin mode. The motor pin needs to be of type output. Okay. And then I'm going to write digital write, motor pin, I write a high, so now the motor should turn. I will delay for this easy test the motor on time. Then I will turn the motor off by simply setting it low, and it will wait the motor off time. Okay, this should do the trick. Let's see what is happening. It's compiling and downloading. Okay. Nothing? Really? Nothing? Why is that? This should work. Of course. Pin number 3. Please connect to the right pin number. Heinz. 5 seconds running. 2 seconds standstill. 5 seconds running. 2 seconds standstill. 5 seconds running. I mean, it's interesting, right? Maybe, for instance, maybe we could build in. It looks like a ventilator. Yeah. The thing which I'm feeling now with my fingers here is that it's sucking in air here and blowing in air out. So it turns the wrong direction, let's say. Turns the wrong direction. What I can do is simply switch the polarity. And now, better. It turns the other way, okay? So such a DC motor will turn the other way if you switch polarity. That's very nice. So what we could do, we could build our thermometer, yeah, with the thermistor, and if a certain temperature is reached, we could turn on the cooling fan, for instance. Yeah? Or we could even use our DHT11 humidity and temperature sensor and turn it on if the humidity gets too high to ventilate, yeah? For instance in bathrooms. Yeah? Right now your task here should only be to build in. You could do this, yeah. No, if you want to do it what I just said, you can do this, try this, a little bit fun, but you can also just make a push button to turn the motor on and off, that it's not just stupidly turning off and on automatically, just turn it off and on. This is how it could look like. Press the button, turn on. You see I also introduced an LED. The LED shows the state of the transistor. Press the button again to turn it off. This, now you can turn off and on the motor. Yeah? This would be the goal for your task. Okay? To summarize what we've got, we have got our Arduino. It's turning on and off this output. Yeah? This output is turning on and off this transistor here. This transistor is turning on and off this relay, and finally the relay is turning on and off our motor. Yeah? This is our 3-step approach. Typical approach, yeah, because this is standard. From your control system you usually switch some smaller parts, and these smaller parts are then switching the really huge massive relays. They are called then whochs, or power relays in English. If you're using a relay, you should really think about what is the maximum voltage here, and the maximum current, which might be switched by this relay. Yeah? This together gives the maximum power. Yeah? So relays symbols are like this: A1, A2, yeah. This is typical relay symbol, yeah. And you should really take care about those contacts here. So these are the contacts on this side, yeah. And then of course we also have to take care about the coil, yeah. This part here is a nominal voltage. The coil is designed for 5 volt, for 24 volt, for 12 volt. There are different levels. There are coils which are designed for 230 volt DC, AC, DC, different types simply. Yeah? You have to be sure that this is fitting your switching power. Yeah? If you want to switch by 5 volt, use a 5 volt coil. If you want to switch by 24 volt, use a 24 volt coil. If you want to switch by 230 AC, use a 230 AC coil. Okay? If you are using the wrong coil, then the least thing which has happened, it's not working, and the worst thing which has happened, it's burning. Yeah, because then there is too much. If you're using a 5 volt coil and apply 24 volt, then a lot of current is running. This is getting hot, melting down. That's it. Yeah? Destroyed the relay. Thank you very much. See you next time. Yeah? So the relay will say hasta la vista. Yeah. Yeah. I hope I have covered the relay. I hope you understood what the relay is doing. I hope you understood what in principle the transistor, that the transistor can also be used as switching element. Yeah. And I hope I also have covered that the motor can be turned in one direction and the other direction depending on the voltage. There's even more. Yeah, there's even more. If we apply a lot of voltage, the motor will turn fast. If we apply less voltage, the motor will turn slow. So a DC motor can select this. You can select the speed of a DC motor very decent. DC is decent. Yeah? Simply by adopting the voltage level. Yeah? If you want to change the speed of the fan, yeah? If you want to change the speed of the fan, you could come to it here. Yeah, I'm not using on and off, I'm using pulse width modulation. So I turn it off and on very fast. However, now it's bad that you use this one. Yeah? Next time we will cover how to change the speed of a motor. Yeah? Next time we will try this. But then this is next video. Okay? For this video, thank you very much for listening. Goodbye.